All right, welcome everybody. So hi, I'm Sherman Gomberg. I'm the founder of Scrum Adventures. A little bit of background about me so you can get to know me a little bit. I do have an IT background. We used to call it computer science in those days. I know it's got lots of many different terms in the now. But I graduated with a computer science degree, grew up in Chicago where it's very cold. And so for those of you wearing beanies, this is nothing compared to what it's like in the Midwest. So very cold there. So my background, I did a lot of programming, a lot of project management, a lot of consulting along my journey. Eventually, I fell in love with Agile and Scrum. If those are terms you're familiar with, great, because you'll get to know it as we go on our journey here. But Agile and Scrum is just a way of getting teams to collaborate. It is a framework that helps us build things in small increments, learning really fast, failing really fast, a lot of being a little bit disruptive, innovative, and creative. I met Hutch, who's my partner here in the company, probably 12, 13 years ago, something like that. We met for a client we were working on, and when I started Scrum Adventures, which I've had for 10 years, we did it to be able to do training, help companies, individuals train and learn Agile and Scrum, and to kind of coach companies on that journey. Along that journey, we typically hire interns. Every year, every summer specifically, I would have interns that I would bring on that journey. As part of having those interns on that journey, we eventually wanted to turn an Excel spreadsheet into a web-based application. We built this Excel spreadsheet for one of our clients. They had a problem. So what's the easiest way to solve a problem? Bring up an Excel spreadsheet, right? Solve it. They're great. This is good. So they used our interns and said, what do you guys want to do this summer? And I proposed the idea of, do you want to turn this into an application? That'd be great. Be a really good internship. So that's what they did. That has turned into a full enterprise online solution that we've been running for almost 6 years now. And about a little over a year ago, probably about 13, 14 months ago, we integrated AI into that solution, which we call Kadomi. So let me give you a little bit more journey here, but that's where my background comes in. So I have a technical background, but I love to be a trainer and a coach, and building product has been really powerful for us. So let me tell you a little bit about the objective here. What do we want to do by having you guys engaged? We want to continue to advance our product. We have AI in there, but there's so much more. I have a lot of vision to be able to get AI to be the driver for it and not just carry it along for the ride. Right? AI shouldn't just be carried along, but AI should be integrated with everything we do. And being part of an AI club, you're probably already thinking that way. One of your first thoughts should be, what can we do with AI? And that's how I think too. And that's how we want to change the world. So the objective here, get something, how you can do real world, how we can use it in our product and collaborate together as we work. So our goal is to find that alignment and see what you guys want to do here. All right, I told you a little bit about me, but a little bit about Scrum Adventures, founded in 2016 on these 3 core principles: community, always giving back, like internships. In the winter last month, we did a toy drive with Sparks of Love toy drive. We do things like that, Habitat for Humanity, different local children's charities and hospitals. We do love to give back. Right now, I've been running a promotion for NPR. Any of you NPR fans out there, I love being able to do a promotion where I give a portion of people who register for my training. I donate a portion to NPR. I'm kind of passionate and a fan of NPR, and they've had funding challenges. So love to be able to bring that up. So we'd love to be able to give back in the training. All right, here's our ecosystem. We call it Kadomi, C-A-D-O-M-I. That word is derived from 3 acronyms itself. So it's an acronym of acronyms. So for all your acronym fans, you're right where I'd like to be. Kadomi is derived from cats, dogs, and mice. All right, I am an animal fan, so I kind of got creative when I came up with the name. You have a cat team, a dog team, and mice teams. I took the C-A-D-O and M-I from each of those teams to come up with the word Kadomi. So at least you know where the origin of the word comes from.
And it's not French, right?
It's not French. No, it's just an acronym.
It's an acronym.
So just an acronym. But you know, like many things, usually you start with some word somewhere. But Kadomi is really an AI digital transformation ecosystem. That's what it's really become. It started with that cat team. The cat team is basically a team to drive any type of organization on their transformation journey. How do we go from where we're at now in order to actually make a real difference for our customers, our users, and our clients? So we have a team that helps explore that journey through coaching, assessments, and transformation. Out of that journey, you build what we call dog teams, which are disruptive, self-organized groups. I love having the word disruptive because I want disruptive thinking, right? And they need to be self-managing, self-organized to do that. We also have the MICE teams, which stands for Multiple Innovative Communities of Excellence. These are specialty teams that work on unique practices like AI, like DevOps, technical architecture, UI, UX, for example, security, information security. These are some specialty teams where these MICE teams will go ahead and do the deep exploration research ideas that'll feed the dog teams to build the actual product, all driven by a cat team. So it's an ecosystem of these three teams working together that brings up our Kadomi. We also supplement that with what we call a lot of programs or accelerators. Basically think of that as a toolbox. You don't have an electrician or a plumber walk into your home or where you live and just say, I don't know how to solve your problem. What do you guys want me to do? They need to come up with tools and experience. So anybody working with our Kadomi has these tools and experience. We make these available for them. So to continue that journey, we built our own AI coach. I did this November of 2024 now. I was at a coaching retreat in Northern California with about 70 other coaches from around the world. And I pitched an idea saying, hey, I want to build our own GPT. Now, none of us, at least in November of 2024, ever built a GPT before. So we said, let's go do this. And I got about 6 or 7 people that said, yeah, that'd be great. I'd love to spend my 2 days at this retreat building a coach. We did. We basically did it 90 minutes at a time. Every 90 minutes, we built a version of this coach. First thing we had to do was figure out, well, how do we actually build something on ChatGPT? So we figured that out. And we quickly learned we had to pay $20. So that was the number one thing we had to learn is you can't do it for free. So we paid the $20, we were able to deploy a coach, and every 90 minutes over these 2.5 days, we created a new version of it. And now we have a coach that is called the Kadomi Agile Coach GPT on the ChatGPT marketplace. It's available for free for anybody to run ChatGPT. It is trained on ethics. It's trained on professional coaching. It's trained on Agile. It's trained on Scrum. It's trained on our entire Kadomi ecosystem. So it understands all of this that I just shared with you. We have taken this and integrated it into the product. So not only is it available on ChatGPT, but it is also an assistant that we call through the backend through API connections. So it is integrated in our product, not just a front UI. All right, so here's the problem that we see in the real world that a lot of companies have out there. The problem that companies face is they have barriers towards their transformations. They don't know how to do a digital transformation. They don't understand their customers. They don't understand their problems. They don't know how to go from a problem to align towards their strategy to actually go ahead and build a product that matters. Hutch and I have seen in studies that we looked at, a lot of companies build a product and say, sell it. Right, maybe you've seen this. Right, they tend to fall flat on their faces. They're trying to push a product into the marketplace, but the market doesn't understand or want their product. So we need to create that connection. We need to make sure they understand the problem, figure out the vision, and then say, what product can we bring to market to solve that and measure it along that journey. Our vision is to have Kadomi AI help them through that entire journey. We already have a lot of pieces in our Kadomi AI that does that for them. We have the embedded Kadomi Agile Coach. We have ability for them to do capacity planning. We have ability for them to measure their journey along the entire way and get all those coaching insights. But there are a lot of extra pieces to complete this entire journey to help them go from problem to delivery and measure and be as efficient and effective as possible with that assistant. So that's the problem, and that's our vision we want to go. All right, so here's our Kadomi ecosystem. This is our home landing page here. Got here showing you we have the coach here. We have different models that they can sign up for. We can show you the product depending on how our time goes or Q&A that we have. But we have different subscription models. People can sign up for free. They don't get the AI coach for free because many of you might know there are tokens. Every time somebody does a request, it causes tokens. It's extremely small, right? It cost us very little money. I think last year we spent $5 total in the number of calls for an entire year. So it doesn't cost a lot of money, but I still don't want to give it away for completely free. So they can do free things on here. but there is also different subscription models where it can be an individual, a small corporation, or a large corporation. And they can completely sign up and everybody gets memberships and plans there. Okay, so we can take a quick look. I am demoing this, right?
Yeah, we can include that.
Okay, so we can do that. I'll go through the deck and then we'll come back through it and see what else we have. So here are future opportunities. These are things that we want to build that are on our roadmap to do. One, we need integration with third-party applications. All right, we already have an API layer, right? But we also need, I think it's the MCP layer, if you're familiar with that term. I just know that a little bit. My team has been educating me on that. So API layers are great, and we've integrated with some applications, but we need to integrate with other products. Because having a product that's isolated is going to make it really challenging to be effective in the marketplace. Your product has to be highly integrated and plugged in with about anything else out there. Think of working with Microsoft Teams, for example, or maybe there's some others you've heard of if you're familiar with Atlassian or Jira or Azure DevOps, to name just a few, or even some other chat tools, Slack, Discord, for example. You want to be highly integrated with those to allow people to work in a way that's comfortable for them, and your product just plugs in and becomes an extension of that to make that happen. So that's one. Others, to have a product backlog capability. When companies want to build a product, they need a place to say, here's all the things we want to build. So our Kadomi AI needs to have a place where they can actually put all of these features, backlog items, and manage that as they go through. We don't have that right now. We rely on other products to do that. We want to have the holistic ecosystem so we can do that. So that's one of our objectives. Another, which we've actually implemented, that AI chatbot team conversation, we implemented that since we wrote this proposal. So we already have that. This is pretty cool because I haven't seen anybody else do that, at least not do that in the way we do it as effective. If we get an organization or a team to sign up on our Kadomi AI, they can build a team, right? Team A, team B, team C, whatever they want to call it. So they have a team. All the members of the team can have a real-time conversation with their AI chat. So if you start a conversation, you can then share it with all the other members of your team. They can continue the conversation and see the AI's responses and each individual's prompt. So as I said, nobody else really does that because they don't have a team-oriented products, even though they've tried to create group conversations. They're still invited, but they're not a member of the TOOP. It's just a loose group of individuals. So that's a powerful thing we've already implemented. Others, natural language processing. We want some more NLP from a human perspective. I want to be able to talk to the AI, the coach, the Kadomi AI coach here, and ask it to do things, and it updates your product in real time. This is really powerful and what I want to do. If anybody used an AI browser before, Perplexity or ChatGPT's? Couple heads, hands. All right, so you might be familiar with it. Have you ever had your browser actually manipulate things on the screen or read your screen, even if you've had it like read your email? You know, anybody done that? Okay, pretty cool. Give it a try. If you use one of those browsers, bring up your Gmail or whatever email you have and say, hey, what's my agenda for the day? It will literally open your email and read it for you and tell you what's going on. So Perplexity will do that. And like I said, ChatGPT also has a browser, and you'll see more of those. So I use the Perplexity browser, and it can actually read our product. The person's logged in, and it can actually change things. It can create new future sprints. It can do assessments for you, but it has to all do it through the UI. It's trying to identify what's going on the screen, find the buttons, find the things, read the text. It's slow. It works because it's browser-based. What we want to do is have the same conversation, but built into our coach, all of that done through the back end. Hey, can you create the next 5 iterations? And by the way, these 3 people are going on vacation. We're hiring 2 new people. And this person right over here is going to be in a training class. It should build those 5 sprints and tell you exactly what product you can build based on that new capacity. That's what that feature is all about. Another is to be more predictive in its analytics, right? To be able to look ahead and say, what else? What can happen? So get some predictive ideas and analytics. Machine learning, it should constantly learn as it goes. So we need our AI to constantly create connection and learn, tune and reinforce its behaviors, right? If it's going to be an AI, it can't just work on one thing that we design. It has to learn and grow on its own. And another thing we want to add more of, we have a little bit, gamification. You want connection with people, you've got to gamify it in some way. Simple thing like you just earned a badge. Good job. You know, get badges. People love getting those Easter eggs, right? So create that gamification. I have some of that in there. There's a leaderboard built in right now. If a team does something, they earn a badge and they can compete with another team, right? And it makes it a deeper level of connection, adds fun while they're actually making a difference in building product. So these are some of the future AI opportunities that we want to go ahead and build. All right, some current architecture for all of you folks that want to know. So it's built basically using Python on the back end and on the front end React. So those are the basic thing. It is a multi-tier architecture right here. We use GitHub for our storage, HTML and React there. Python, our database is Postgres, which is pretty easy to use. We host it on Heroku, which is a Salesforce product. We use Django for a lot of our security and authentication and authorization. Visual Studio is typically our IDE, our development environment, but you can always build on anything, doesn't matter there. And we have said we have the APIs with ChatGPT. We often use AI, Claude Code is constantly used, CSS for cascading style sheets. We have single sign-on. We do connect with some other aspects by allowing single sign-on, right? And some of the other things in there. We do have CI/CD pipeline, continuous integration, continuous delivery, continuous deployment. That pipeline is in place, so we can be automated and as fast as possible. We also use Swagger and config cat feature flags. Feature flags are pretty powerful because it allows us to deploy to production even if it's not done. This is good because nothing should constrain you from being able to get to production as fast as possible. I've had my team, no matter how small they are, typically are they deploying multiple times a week to get to production. We do weekly sprints or weekly iterations. And they're putting new features all the time. And we can put them behind a feature flag if it's not ready for our customer, but it doesn't constrain us from being able to release value. You want to get value as quick as possible. So that's our architecture as we are going on there. This is a little bit about how Scrum works. So if you're familiar with Scrum, you might be familiar with that. I won't go too deep in that. But what we're looking for is to get a team to help us advance our AI capabilities. That team will get trained. I will perform training for you to get trained. I'll even certify you. I am a certified Scrum trainer, so you can gain a certification, which is always great on whatever you do beyond when you're done with school here. So that could be helpful there. But this is the Scrum framework. It's basically an iterative approach to constantly deliver value in short periods of time. All right, I do want to show you the product, but let me see if you have any questions first, and then I'll do a little bit of demo of the product so you can see what it looks like today. Any questions, curiosities, anything you want to share before I do that demo? Please.
You said like for like the AI browser where it can like browse through your emails and like make things easier for people. Mm-hmm. Does I know if you make it yourself, it doesn't come with any, but using like an AI browser, can that come with like security risks?
Yeah, absolutely.
Do you use that like?
Yeah.
Do you take any measures to like prevent that?
Yeah, so it's a great question. The question, in case you didn't hear it, is if you use an AI browser, are there any security concerns? Yeah, so if you log into your email, let's say on one tab, right? You're logged into your email and you ask your AI browser to actually say, hey, can you go ahead and send an email to my friends that want to go, to the movies this week, right? You've exposed your email to the browser by asking it to change things in your email. So yes, you have exposed a security possibility. So you have to watch for that. And that's partly why I don't want to use a browser-based solution. That's why I want to use the solution through the coach, through the backend, through the API, right? That way we can control the communication, the connection, and the security. Somebody asks something that's built into our architecture as opposed to just a user experience. Because UI, really can create penetration, vulnerabilities, could expose you to hacking. What if somebody gets a login and then they have a browser go ahead and go rampant, right? To go do that. So that's a really good insight. Great question. So they're powerful, but you do have to watch out for them because they do open up security risks. Unfortunately, our world doesn't trust everybody. I don't know why. It'd be really nice if we trusted people around the world. It'd be a whole lot easier, but we don't do that. All right. Human race doesn't do that. Thank you. Great question. One in the back.
Could you go over what a sprint is again?
Yeah. Yeah, I didn't give a good explanation, so thanks for the question. The question is, what is a sprint? So a sprint is a short period of time. Think of the word iteration. Typically, a sprint is less than a month long. Most teams will do 1 or 2 week sprints. But what's interesting about a sprint is in that sprint, you're doing some planning. You're having a daily check-in with the team, right? As you build your product, you build some iteration, something that works in the sprint. At the end of the sprint, you have a review of what you built that works, is usable, is deployed to gain feedback. You got to get feedback from stakeholders, users, customers, because once they see something, they give you feedback. You ever have anybody and say, I don't know what this is going to do, but as soon as you show them, they're like, oh, now I get it. That's what this is about. Build something that works, gain that feedback, helps you make decisions about what to build next. So sprint is a short iteration of time where we build a working product, gaining feedback to help us to figure out what should we build next. That's the most valuable thing to build. So we're not just busy. It's really easy to be busy, but we really want to create value. And so sprints will help us generate those values. So thank you. Great question. Another one here.
I remember you were talking about training a GPT.
Yes.
How does that work? Like, do you like what kind of data are you like giving the GPT, and like how do you get that data, and like how do you see it improve over time?
Yeah, so great question. So the question is, yeah, how do you train a GPT? What data, what information do you give it? So it's actually not very hard. You know, when I didn't know, I didn't know. But once you do it, you find it's pretty easy. Number one thing you want to do is you've got to give your GPT a persona. Who is it? Who do you want it to be? What problems do you want it to solve? So think of that. That's the number one thing. So when we built this one, we wanted it to be an agile coach. So basically come from a coaching stance. So I had to give it a persona and say, hey, you're a coach, help others, coaches, scrum masters, developers on their journey to build, excellent product. But I also train it to tell it that it needs professional coaching, meaning ethical behavior, respecting people's personal space, being genuinely curious. And I also trained it to be friendly and personal. I tried to make it kind of a reflection of myself and Hodge, right? As professional coaches, we used ourselves as an examples. So give it a persona. That was the first thing. And that's really just a couple paragraphs of information. Then other training you do is you upload documents to train it, to give it a specific. Now, in this case, I trained it on things particular to the framework, like Scrum that I just kind of showed you, that framework. I trained it on Agile, but I also trained it on Kadomi. All of those programs, accelerators, the entire ecosystem, how cats, dogs, and mice work. So I created documents for all of those, uploaded that to train it. Also enabled it that, of course, it can access the entire world. So it learns, and it learns your conversation, which is kind of neat. When you use our built-in Kadomi coach, it actually knows who you are. It is really a large language model. It will actually address you by your login and username. It knows who you are. It will kind of learn what you like and what you don't, but still staying within the stance of this persona. So not too hard to do. If you have access to ChatGPT and you're on a paid subscription, give it a try. If you have Microsoft Teams, there's Copilot. You can go in there and build an assistant. So if you haven't built an assistant before, give it a try just to kind of experience and what it feels like. Thanks for the question. Another one over here.
Is the AI integration primarily through the chatbot, or do you guys have other features with like AI integrated into it, maybe indirectly?
Yeah, great question. So the question is, do we have the integration just through a chatbot, or do we also have it as kind of a deeper level of integration? At this point, we have both. We have a chatbot that runs on a side panel here. So you can talk to that chatbot while you're running your application. You can have application on the panel and your AI on the other panel, right? But the other one we have, which I'll show you here, when teams are doing assessments, basically, how effective are we? They can fill out one of these assessments here. After they fill out an assessment, we have the coach embedded there where they can say, hey, give me a recommendation. That is embedded where it actually read the assessment that they actually built. It feeds that data in there and comes back with a recommendation to improve based on the team self-assessment. So we have both, but we want to have a lot more of that. Yeah, we actually started with that embedded one first before we built the chatbot, which is probably different than most people did, but we started that way. Another question.
Is there any issue with when teams want to use your product to improve their like efficiency, that since other companies would be kind of reluctant to share the like finer details of how like their team works or how their products work that they're actually developing on, that's a core part of knowing how to improve that efficiency.
Yeah, so if I got your question, basically you're thinking keeping things kind of personal, private, so, you know, privacy aspects here. So that's a good question. Basically, anybody who gets on any subscription model, right, they're always concerned about privacy. So we have that privacy built in. Everybody who subscribes, it's just for their enterprise. It's not shared anywhere else. And an advantage of using an AI chatbot through a proprietary information, it's not even shared or used for training for ChatGPT. When you go through an API, ChatGPT does not take that information, unlike when you go through a browser-based AI where it is available for training. So their information is proprietary. Security and privacy are important. We have had clients ask us for that. We do have a published security policy, but that would be a good thing that we want to improve. Even this, was it this morning or yesterday? I think it was yesterday, I had somebody said, I'd love to use your product, but I'd like it to be HIPAA compliant. HIPAA, if you've heard the term, is for medical, it's basically medical privacy practices. And they're a medical company. They're like, it'd be great if you can prove it's HIPAA compliant. Right? We probably are, but I have to prove it. So for them to be able to subscribe and use it. Yeah. Is that what you're looking for?
Yeah.
Yeah. Thanks. Great question.
You mentioned that your product sort of like bridges the disconnect between the consumer and the company. Is it purely just that Kudomi helps like companies plan better, or like what exactly does it do to help?
Yeah, good. So some of it is built in, some of it is vision that I still want to get done, which is why we're here today to do that. But if a company, think of any company here, I don't care. I'll pick one that we all know, Netflix. Okay, so let's say Netflix here. Netflix is basically going to say, hey, we've got a problem that our customers have. That's what they need to start with. What problem do our customers have? If I had to think of Netflix, what's the problem I always have? Maybe you don't. We're different ages. Problem I have is I spend too much time trying to figure out what to watch. All right, I see maybe some nodding heads on that. Right? Anybody spending too much time? I just spent 30 minutes and I haven't even watched anything yet. All right, so maybe that's a problem Netflix has addressed that their customers are sharing with them. What Kudomi will do is help them go from that problem statement to understand the vision. What should we do to address that problem? Then build some goals that we can go and target to achieve. Right? Ultimately, figure out what product we can bring, or we have already. Sometimes we have the product. Sometimes we have to bring a new product, and then build a backlog of features to build that product and measure it along the whole way. Are we building the right product, and are we building it in the right way? Do we put the right people on the right team at the right pace? So Kudomi goes from that customer's problem to building the product that meets the goals to solve your customer's problem while measuring effectively. And doing it with AI, we do it at a fraction of the time that anybody else has done it in the market. Right? Because everybody else that does it, they take 6 months, years, they miss the entire market. We're going to do that in a fraction of the time. So, and give them a higher level of confidence.
And that's a differentiator for us too.
It's a huge differentiator. Yeah. Yeah, that's a great question. Does that give you kind of the vision? Yeah, that's a good one. All right, you guys want to see a little bit of it?
I think we got one more.
Oh, one more
It's our
question?
hand.
Do we have one more?
Right there.
Oh, sorry, I didn't see the hand. Go ahead.
A few months ago, I was working on a project using agile development, and one problem I guess I faced was people being overwhelmed oftentimes, and just lack of motivation as time went on with multiple iterations and multiple sprints. What kind of steps do you take to make sure people are motivated throughout the things and no one's overwhelmed when they have to meet up again at the end of the week?
Yeah,
end
so
of the
that's,
sprint?
that's a good question. I'm glad you got a chance to experience that, and you kind of experienced it in a way that sounds like a little dysfunctional, right? But that's a good way to learn. So that's where coaching really comes in place, because just because you learn a framework or you learn a way of working doesn't mean you can do it really well, right? You can read a book, you can read a blog, somebody can tell you how to do it, but until you start doing it, you don't learn. Now with coaching in place, whether you have human coaches like Hutch and I, or an AI coach, you could have asked our Kudomi AI coach and say, hey, we're struggling with multiple sprints, people feeling overwhelmed. What should we do? This is a coach that has a persona that would say, hey, great, thanks for sharing. Here's a couple questions, please respond. It will coach you on that journey. But following Agile and the Scrum framework, it's meant to basically create a psychologically safe place. People are sharing, highly communicative, constantly working, goal-oriented, understanding their capacity. My guess is you were overwhelmed because you're pulling in more than you can do, right? And that doesn't necessarily mean you're effective. You're probably less effective than if you did less. If you did less, you're probably more effective. So the entire Kadomi ecosystem will help teams go through that. So I'd love to be able to tell you more. If you experience that, you'll experience it the right way. You'll get coached by humans and the AI to help you work in an Agile and Scrum way. Yeah, great question. All right, let me show you a little bit about the product. How much time do you have?
Like 10 more minutes.
Okay. All right, I'm going to sign into a test environment here. All right, I'm going to go to dark mode. Tell me if that works for you guys. I like dark mode better. Everybody see it okay on the screen? It looks all right. Okay, I'm just a bigger fan of dark mode. Not everybody agrees with that. So this is, once you sign in, this is what your landing page looks like. Now I wanted to show you what the different plans look like because I did sign in, but here's the different plans we have today. Told you we have a free version available. Anybody can sign in for free and use some basic functionality of it, like capacity planning or some of our metrics. Premium plan is basically for an individual user. We made that really cheap because we want people to use it. Can you get an unlimited AI coach or GPT for $5 a month? If somebody wanted unlimited use without having, like student accounts or something, it would cost them $20 a month on ChatGPT to have unlimited use. So we have made that extremely cheap just for individuals. Now we've done even a core. Core is basically for a small business where they can get 2 teams set up. And we only set that up at $25 a month. We want a lot of users on here. Want to change the world, right? 25 users, that's still up to maybe, 20 people or so. Everybody has access. Everybody gets a login registration. They can create 2 different teams and they can work in it. And then we have a full enterprise for even very inexpensive, $250 a month, where you can get up to 25 teams, right? So a pretty large organization. So they can use 25 teams on our platform. And basically like $1 a person a month. They all have unlimited use of everything and team connection. So that's our pricing. We do have annual and monthly too. And we can always revisit that pricing as adoption changes. Do that. All right, let me go back to here though, tell you more about it. So a couple of things I want to show you. So here's where our coach is built in. It is that left panel here. So here's where the AI coach is built into it. You can go ahead and we do have this in what we have is split screen mode. So you can put your application on the left side. You can put your coach here on the right side so you can see what's going on your screen while you work with your AI. You can do that. You could even slide it. We've built a slider here. I won't do that. Or you can make it full screen, which I will do, so you can actually see that. So if we had to want to do that, so your kind of dysfunction, let's ask the coach. So I'm going to just do a little prompt here. I'm actually going to do, I won't do it because I don't know your computer, but we do have voice mode enabled. We did create a microphone. So if somebody wants to speak to it, that's a feature we added not too long ago too. So a lot of great features that we want to be able to add to this, but I'm going to go ahead and say, I'm on this keyboard. I don't know this keyboard. I'm on an Agile team that is quite, not type on this keyboard at all. Just, all right, we're gonna do this again. I'm an Agile team that is quite dysfunctional. And I'm gonna keep it pretty simple. I'm just gonna put help. I won't go more because I'm not typing so well on this keyboard. I took a typing class when I was in high school before there were really computers because I knew I was going to fall in love with computers. I wanted to type really fast. At one point, I got to 80 words a minute. So I still type pretty fast. All right, so it responded. Actually came pretty fast. Now, it knows who I am. I'm logged in here as somebody called Mickey Mouse. I made it up. So I'm Mickey Mouse right now, so I said hello, Mickey, because it knows who I am, it knows my user, it knows my login. And it says, thanks for reaching out. So this is a coach to help you. And you can go ahead and read what's on here, but it comes from a coaching stance. This is what I like a lot. It didn't just give me answers. It's helping me find and work through the problem. And that's what's really powerful about this versus asking just a standard AI. Standard AI will usually try to just give you solutions. But when you ask a coach, it's going to help you work through a problem. So we're not going to try too deep, but I wanted to show you how this is integrated here. And you can have that conversation. We've got all the copy and paste capabilities at them. And something we added not too long ago, we have a history capability too. Do that. So you can see all your prior conversations. You can even create groups of conversations, basically folders where you can add them or remove them. And something I know nobody else is doing, I can take a particular conversation like this one right here, and this is pretty cool here. I can share this or switch it to a team conversation. So this was a personal conversation I started. Maybe I really like this and I said, this is a good response. I want to share it with my team. I can switch my personal conversation to share it with any team that I am a member of in the organization. In this case, these are 4 teams that I'm a member of as Mickey, and I can share it with one of these teams. It'll switch to a team conversation. Every member of that team can now add to this conversation and see the whole conversation. So those are some of the key features I wanted to show you kind of built into the Agile coach here. So new conversations and stuff there. Don't want to go too deep there, but any questions about how the coach works as a side panel? My vision though, is to be able to ask it to do things on the application side. For example, create new sprints for me or perform an assessment for my team dog alpha, right? Nobody is showing up for meetings. Can you do an assessment to see how effective we are? And it can fill out the assessment for you and give you a recommendation. That's the integration that I want to have deeper. Questions or comments about the coach? Other thing I'll show you is what's known as our sprint capacity planner. So sprints being short iterations of time to build working product. You can put current sprints, future sprints, and historical sprints in here to help you be predictive. So you can even think of this as a student. Let's say every week of your semester is a sprint, right? And you're working, let's say, as a team or a group. You can go ahead and figure out, well, what's our capacity, right? For that one, there's a holiday this week, or this is spring break. You can put all of that in there, and you can go ahead and say, well, how much have we been doing or built in the previous sprints? And it'll be predictive to tell you how much you should build in future sprints or iterations. The future sprints are known as targets. This builds what's known as Kaizen. If you've heard the term, it's a Japanese term, basically meaning improvement. So how much can the team invest in improvement? How much should the team have as a buffer for possible interrupts, things that happen that we didn't think about? And what about how much should the team build that they can plan, which we call increments? This is kind of planning or known activities. So these are future sprints, but they also can have. Scroll without a mouse. Just want to touch screen. No. All right. I'm not sure how to scroll without a mouse on this touchpad. It's not the other way. There we go. Got it. It's opposite what I thought. But here's the other one. You have a planning window, which are your 3 prior sprints. If you see they actually have actuals in them, this is what the team actually did to help you predict the targets. So this actual, let's say there was a typo here. It really wasn't 90. It was meant to be 9. I can change it. And all of these actuals are now going to be recalculated for me, or all these targets are going to be recalculated for me based on that. So you can see that we're all redone and saying, based on what you recently completed, here's how much you can predict to do. And that's what's pretty powerful. This was the first tool we built, was the Sprint Capacity Planner, helping teams to figure this out. And this can be done for any team. So I can switch my team to like Dog Alpha. And here's the sprints for Dog Alpha. So everybody on this team Dog Alpha can see their sprints iterations be predicted. These also have dashboards built into it. So a trends dashboard, the team can see their productivity, right? So you want to know how dysfunctional you were. We can see, are we actually productive? Are we actually delivering something? Or are we just busy and not actually getting things done? So this will give you productivity. There's also organizational productivity. All the teams in the organization, I can see how productive they are. So if I've got 3, 6, 9, 12 teams, I can see and say, are all the teams working at the same pace? Are some of them struggling? Now they can be coached, they can get help, they can get support. So we want to be able to do this with AI. I want to ask AI and say, hey, can you analyze this and find which teams can you support? Right now I have to do this with my human eyes. Not so bad, I only got 4 teams, I can probably see it, but let's say I had 50 teams in there. Take a lot of analysis and data. If I can ask AI to do that analysis and data and find out which teams are, can use the help right now, my whole organization is faster, more efficient. So that's the capacity planning. I'll show you one more thing, then I'll turn it back over to Julian here. The other are all these rubrics. So we have a bunch of rubrics here. I'll bring in the AI rubrics. These rubrics, if you're familiar with the term, rubrics are self-measuring, visible, guiding you towards improvement, often used in education. You might have had teachers that use rubrics to figure out how you do as students. So we did rubrics here to allow teams to self-measure. One of the rubrics here would be like AI maturity. So for this team Dog Alpha, for this sprint number 8, they can go ahead and fill out this particular rubric to see how is their maturity from an AI standpoint for that period of time. These are all the themes in here. They would answer this as kind of a wizard and say, hey, are we underperforming? Do our AI initiatives, are they ad hoc? Do we have no strategy or leadership? If they agree, they would just say agree, and they would get 1 star. And then they can go ahead and go on to data management and answer this too. And they can see how many stars they get as they fill it. You got a radar graph that builds in real time along the side. I won't fill it all out, but once they fill all this out, what I do want to show you though, this is where the AI coach is integrated. I'm going to close the panel. We have the AI coach here. If you click that, it will automatically read this assessment for Team Dog Alpha, following the themes, and come up with a recommendation that the team can use to improve. We built an inbox so they can always revisit these. Here's the recommendation that was just generated. This is all back-end stuff. So went ahead, actually, due to a color, I'm going to bring it in light mode so you can see the stars, but you see it copied our stars and it went ahead and it created a recommendation. It read what the team self-measured and it came up with recommendations. I won't read it all, but this is an AI recommendation. What can the team do to improve AI maturity based on their own self-assessment? So, kind of what we've done. We even have another AI that can generate a Kaizen, and I'll show you that. What can the team do to be a better team to help them on this AI maturity? So this is pretty powerful too. So you can actually go back to your inbox here and say, that was a great recommendation, but the team needs to come up with a maturity here. And I must have clicked it twice because we got twice in there. But you can see here, as Dog Alpha, we desire to establish clear AI vision, align leadership, and create governance. And it gives you criteria what the team can do to improve. And they can then go ahead and put that right into a backlog to continually improve their team. So this is where our AI is already integrated, right? But I also would like to be able to ask this AI, right? Oops, I didn't do that. All right, Julian, I'm not going to get it back now. Without a touch screen.
Yeah, I can help you out.
Yeah, go ahead.
Like the website or the.
Go back to the website. Yeah, just to finish that. Thank you. Yeah. So, so the last thing here is just look at it, but the team can then implement this and actually improve. So the AI, what I was going to show you here is have the coach be able to read this, say, hey, can you put this in my product backlog? Have it actually do that. So now the team can put it in their next iteration and just fix it. That's what's kind of going on. That's kind of the over. Other questions, comments, thoughts, now that you got to see it a little bit. Our objective is we'd love to have a team to help us on this journey. I've got 2 teams that are going to be going through this next semester. I have my internal team. They're kind of my employees with a couple interns that we got from different universities. We also have a capstone team that's going to be starting here from UC Irvine to help us on a lot of this product development also. But I'd love to have an AI team that can do deep development and insights on the AI, see things we don't see, follow this vision, build things in a real product. That's what I think. Julian, why don't I turn it back over to you? Thank you very much.
Yes.
Thank you, everybody.
So yeah, if you want to, feel free to go up and talk to Sherman and Charles after this, or you can message us, and we'll be sending out an application. So, do you know about how many people you're looking for?
Yeah, it's not really a number of people. I'm just looking for a team.
Yeah. Okay.
So one team that can be cohesive, that can work together. They will get coached, they will get trained, right? And they will actually build something real that they can use and show up and see what it looks like in an application.
Yeah, another thing that we didn't mention is that as far as the location, we're actually based in Long Beach, which is kind of in the community, if you will, Southern California. Right. So if you're part of our team, sometimes you can come up to our office, work in our office, work with others, instead of just being virtual all the time.
Yes. Thank you guys again. And now for the next thing, we're gonna have one of our workshop coordinators, Shreya, go over a workshop on decision trees. So let's go ahead and clap it up for Shreya.
Hi everyone, today I'll be talking about decision trees. But first, I know that we have a lot of new people and it's been a while since we went over supervised learning and stuff like that. So we're gonna do a quick recap. We're gonna go over a little bit of supervised learning and then we're gonna go over the concept decision trees. We're gonna do some math behind it and then we're gonna take a look at XGBoost, which is sort of like a hint at what we'll be doing next week. So first, this is the general pipeline of how supervised learning works. We start off with some amount of training data, which is like our feature, and we have like the answers, which are our target values. After that, we lean into the learner, which is made up of some amount of parameters. A good way to like sort of think about this is, let's say our idea is that we want to make a line through a scatter plot. We have a bunch of data, we want to make the best fit line. In this case, our parameters would be the slope and the y-intercept. So in order to figure out what the y-intercept and the slope values would be, we use a learning algorithm. Lastly, after we finish all of this, we, while the training step is going on, which is a learning algorithm, we go through and we go ahead and predict, and then we do some sort of measure between the actual value and what we think is correct and use that to tweak our parameters. That's a general idea. But before we go any further, I have questions for you guys to think about. So this is sort of a review from last quarter when we went over. I'm just gonna ask these. If you guys know the answer, you can raise your hand or you can just blurt it out. What is the difference between classification and regression problems? This is sort of like one of the core concepts that when you're making machine learning, when you're trying to solve a machine learning problem, the first step is you classify, is it a classification or a regression problem? Anyone remember what the difference is? Yeah.
You're dealing with discrete versus continuous.
Yeah. So classification is when you have discrete classes. It's like, I want to know if this picture is a cat, a dog, or a bird. That would be classification versus regression would be, I want to make the best line through the scatter plot. You have continuous ranges of numbers. What does a predictor do? If you go to the previous slide, we talk about this idea of like predicting, what is it? So what does a predictor do? It's sort of in the name of it. Anyone want to see what a predictor does?
It predicts.
It predicts, exactly. The predictor predicts. You give it some sort of data that you don't know, and it's gonna give you what it thinks the best numbers, or whatever the best class is, or whatever the answer is that you're trying to look for. What is a feature vector? We sort of saw this right here with the features. What's a feature vector? Yeah.
It's a list that represents the characteristics of an object.
Exactly, yeah. So let's say that whatever I'm trying to sort of represent in my line has multiple dimensions. I have an x1, x2, and a y. My feature vectors would be the list of those x1 and x2s across all the data points that I have. What is a learning algorithm? Over the previous slide, if you guys want to see the learning algorithm, it changes the data and improves performance. So does it have an example of a learning algorithm, a way to change these values of theta? The very famous one that you learn in class. Starts with a G.
Gradient descent.
Yeah, gradient descent is a learning algorithm. It changes the theta and improves the performance of your model. Then lastly, what is an example of a score function? If you look here, the score function, or it's basically a way to figure out how well you're performing. It's a way to measure how off you are, how correct you are. What is a way to measure how correct your model is? There's a lot of different ways to measure this. Yeah,
Let's find the difference between the predicted value and the target value.
exactly. Measuring residuals. Residuals, mean squared error, mean absolute error. Different ways of measuring error is the score performance or the score function. So knowing this, we're gonna look at decision trees. Decision trees are a very, very intuitive way of solving a machine learning problem. You can visualize it very, very easily in your head. Decision trees are basically nested if-else statements. Have you ever made a program for like 32 honors or 32 and been like, you know what, I'm just gonna put 50 if-else statements and that'll solve this entire project. I've done that before. I feel like it's a very common thing to do. It's like the most intuitive approach to problems. Be concerned of internal nodes and leaf nodes. Internal nodes are like the ones over here. They're the things that you look at inside and then they go on to other branches. They do not tell you they do not tell you the final answer. They're not going to tell you the class. They're going to lead you on to another like step that'll lead you to maybe find the class or another step. Have you guys ever seen those like flowchart memes which are like should you get a pet raccoon and it's like, oh, you know, do you like garbage? And it's like, yes or, you know, have you seen those on Instagram Reels? That's what a decision tree is basically. I'm gonna have a really funny coding example if we get to it today about that. Leaf nodes are what tell you the outputs. Leaf nodes are the answers. It's the 0 and 1s at the bottom here. So the complexity of it, think about this. How would you describe a super complex decision tree? Think about it just in your head. Try to imagine the most complex decision tree you can think of. What's like a very defining feature of it? Yeah.
Loops,
Sorry, what?
loops, like,
Yeah, like repetition. Well, let's say I had like a crazy data set, so many features, and my decision tree is super duper tall. That would mean it's pretty complex because you have a lot of different levels to it. So a parameter of decision tree is like how deep it is, the depth of it. The tree structure is based on, you can set it as a value, the maximum depth of it. So decision trees can be used for classification problems, categorical problems, and regression problems, surprisingly. It's not that good at regression, though. So next, we're going to talk about the two main types of nodes, which we can break into, which we sort of talked about earlier, leaf nodes and non-leaf nodes. Leaf nodes are like the best prediction given the data subsets that you have. Because leaf nodes are at the bottom, right? At that point, you've got like a little group of the data at that little node, and then you're going to be like, yeah, I think this is the correct class for it. It's only when all the training examples are the same or indistinguishable from each other. All those data points should have the same class. Non-leaf nodes pick a feature. Let's say we have x1 and x2. It chooses x1 or x2, splits upon it, and then puts you to another leaf or another non-leaf node. But then the question is, how do we decide we're going to divide the data at these non-leaf nodes? So let's look at this data. This is purely random, by the way. It's random. No one's gonna get a heart attack. We have these features, name, chest pain, do they smoke, and do they exercise every day, and whether or not they get a heart attack. How can we predict who'll get a heart attack? We have 4 features, and then we have our 1 class. This is sort of like the type of sample data that we're gonna take and split with non-leaf nodes and leaf nodes in our decision tree. We'll go back to this and we're going to fully just solve one out and look at a decision tree based on this data. So in order to build a decision tree, there's 2 different measures of how will we know. There's something called entropy and one thing called Gini index or Gini impurity. So a way to think about entropy is that it's like how much variance do we have in the data? If you look at this first subset, bowl A, is there a lot of variance in this? No, it's all the same. We just have a bunch of purple things in the bowl. A good split in your data means that you have lower entropy. We don't want a lot of variance. The more variance you have in a certain split, it means you're going to have more splits down the line. Because at the end of the day, your leaf node can only have the same class of things added. So for example, in this problem, a really bad split would be I put the purples and the pinks together and the brown away from it. Because that pinks and purple one has a higher entropy. Right? So this equation right here is the equation for entropy. They're both the same thing based on log rules. So just intuitively looking at this, now that I've told you that entropy is sort of like high variance, what do you think the entropy of this bowl is? Just blurt it out.
0.
It's 0, exactly. Because everything is the same. Now we're gonna solve out the entropy of the second bowl right over here. I forgot how to put the thing up. Is it the projector?
Sorry, I don't really know how to work projectors either.
I think it's displays.
Just push the button.
We'll watch another done by pushing out. Okay.
Do you want the lights off?
That's okay. I'll just go from here. Okay, so the first thing we're gonna do is, since it's a probability, what's the probability of pink? How many pink things are in the bowl? 3 out of?
6.
How about purple things? How about the brown thing? 1 out of 6, right? So I'm really bad at math, so I was add up the numerator together, make sure I actually have 6 and I didn't discount anything. So the entropy is going to be equal to this 3/6 is 1/2 times the log of, you do either one, we're gonna do this one, because 6/3 is 2, plus this one, the good thing is I have the calculation written out, so that I don't need my calculator for this. It should be 1.46. Does that make sense? That's it. You just follow the formula, and that's how you do entropy. There's nothing else to it. So the next one is going to be information. Information gain is the entropy of everything overall minus the entropy of like whatever your split you're specifically looking at. So this like line right here, this is our split. This is how we're gonna break things apart so that we can, separate the purple from the pink. And you can see it's a pretty good split, right? We just have one purple thing on this side. Everything else is pretty good. So the first thing you have to do, as you can see with the formula, is find the overall entropy. Does anyone want to just take a guess at what the entropy is of this graph? There's equal amounts of pink and purple things. It's 1. Entropy is 1. If there's whenever there's equal amounts of both classes, it's gonna be 1. If your professors are nice on your exams, they'll probably do this and make it 1 or something really close to 1. So when you do information gain later on, it's a very easy, it's just 1 minus whatever. But eraser. So we're gonna calculate the overall entropy and then the information gain of each split. Your information gain in a split basically tells you how good is your split. You want a high information gain because it tells you, you're getting more information. An information gain of 1, for example, that's good. That means that you have a leaf node right here because everything is the same class. Because the entropy of whatever that split is at that side is 0. So let's do that calculation now. So we're gonna do E overall. So this is gonna be the same as before. How many purple things do we have, like the proportion? 5 out over.
5, 10.
So it's 1/2 log 2 of 2 plus 1/2 log 2 of 2, which is equal to 1, right? Yeah, that's 1. Now we're gonna do of the left side. What's the entropy of the left side?
0.
It's 0 because there's just all purple things. How about the right side? How are we gonna calculate that?
Over 6. And then
Yeah, it's gonna be the proportion of the purple, which is 1 out of 6. Log 2 of 6 plus 5/6. Whatever that number is. Let's see if I have that. 0.65. Now you're like, okay, now the left and right, think of the respective entropies of those sides. What's the entropy of this entire split? So the way you do that is just you do like the total weights of them and multiply by the entropy. I think it's a weighted average. But I don't want to call it weighted average because I feel like it's not called that. Or maybe it is. I think it's a weighted average. Okay. We'll do E split. This is basically how many like total things do we have on our left side? We have 4, right? 4 out of 10. So that's the proportion on the left, and the proportion on the right is 6 out of 10. So on the 4/10 side, our entropy was 0, right? You're gonna do 4/10 times 0 plus 6/10 times 0.65. That's gonna be your overall entropy. And think about it. Why do you need to do a weighted average? Why do you need to do the total weights? How many are there on each side? Why do we need to do that? Why don't we just do 0 plus 0.65? Because if you don't do that, then if you have like a severe imbalance on one side and a severe like very little bit on one side, a lot on the other side, it's going to be very, very skewed to whatever the smaller amount is. Let's say that the way I split it, I just have one purple thing on that side and everything else, the other 9 of them are the mix of purple and pink. The side that just has 0 entropy is going to be overrepresented. You don't have equal amounts of both. One side is significantly better than the other side. You need to show both of those. So now it's 0.39. Now for information gain, that's going to be the overall entropy minus the one of our split. So 1 minus 0.39. What's that equal to? I think it's like 0.61. Yeah. 0.61. So Gini index or Gini impurity is another idea. So entropy and Gini impurity doesn't matter which one you choose. Choose whichever one is most intuitive to you when you decide to build a decision tree. The idea of Gini index or Gini impurity is that how often, like if let's say I took a randomly selected sample of my bowl, how often would it be mislabeled if assigned by class probability? That sounds really, really weird, but if you look at this table, let's say that my class probability I choose is pink, and I take a random sample. How many total pink things do we have in the bowl? 5. And how many purple things do we have? So if I take a random sample of this bowl, there's a 25% chance that will be correct. We get pink and we get pink. There'll be a chance that there's 25% chance we get pink and we'll get purple when we want to get pink because we have half of each. So there's a total, another way to think about it, there's a 50% chance we're going to be right in this case because we have equal amounts of both. If it's a 50% chance we're going to be right, if we fixate on one specific class, 25% chance will be correct. So 50% chance will be right, 50% chance we're going to be wrong, 25% chance will be right for each class respectively, and 25% chance will be wrong for each class respectively. Just like last time, we want to minimize our Gini impurity, but this time for Gini gain, you want to subtract it out of 0.5 because the maximum Gini impurity you can have is 0.5. So now we're gonna go over building a decision tree. This is gonna be based on the previous example that we showed in the very beginning with the heart attack. This was our table once again. This time it's color coded by the green class, which is like the yes or the positive class, and red, which is in our no class. I'm gonna write again. Okay. So basically, first we're gonna calculate our overall entropy. So overall, the same thing as we did last time, the equation is down there. What is the probability that someone gets a heart attack? In our example. 3 out of 5, yeah. The other one this time. What's the probability someone does not get a heart attack? 2 or 5. So in total, I think this is like 0.971. And like if you think about this, this makes sense because remember, if you have an entropy of 1, that means you have an even split between classes. This is close to even split, so you should expect your entropy is going to be close to 1. So the next is, remember we talked about this earlier, we need to decide which feature we're going to split on. We have 3 choices to split on: chest pain, smoker, and daily exercise. You might be thinking, why can't we choose name? That doesn't make any sense because there's no correlation between name and heart attacks because each one of the names are different. If you had like 2 Shreyas, then I guess you could, but again, that's pretty pointless. So first we're gonna choose chest pain. So for chest pain, we're going to have a true branch and a false branch. Because if you remember, in your decision tree, it looks like this, right? If you have this as your node, it goes this way and it goes this way. True and false. That's your split. Your split is true or false. So what you have to do is calculate the entropies of being true and entropies of being false. That's the calculation that we're trying to do right now. So we're going to look at who's going to be in our true branch. It's going to be everyone who has chest pain. So let's make a true set. Let's see if the other pen is better. This one's kind of dark. Oh, this one's significantly worse. So in our true class, it's going to be Julian and Vito. And in our false class, we're going to have Aston, Jasmine, and Shreya.
Just a bunch of decision trees, and then it takes greatest. So say there's like 10 decision trees.
Alright, these are our 2 splits. Remember before we had purple and pink? This is the same thing here. It's also just going to be purple and pink in both sides. Also, I forgot to ask, so far, does this make sense to everyone, what we're doing? Any questions so far about this? It's very mathematical right now, I know. I feel like this math is not true. Like, it's just logarithms and proportions right now. That's it. And that's all it's ever going to be. So first, let's calculate the entropy of our true branch. E of T. What is the entropy of this split on chest pain based on Julian and Phil? You look at the class. It's yes and yes. So this one's true. This one's true. So if the trues line up, if they match, if the falses line up, that they match, that means that they're on like the correct side of the split. Because you want to say that chest pain true, that means I can say that heart attack is true. That's what you want to do. If chest pain false, heart attack is false. That's what you want to be able to say. So in this case, what's the entropy? 0. Because it's yes and yes, it's going to be 0.
Yes, it would. It could just be a bit.
Now, next one, we're going to do the entropy of the false branch.
Yeah, the math would be a bit longer.
So,
yeah.
Aston's a true,
Because
these 2 are falses. We don't have matching, so the time that we would have entropy of 0 here is if this one's also false. Then you can just, your decision tree is done. Because you have entropy of 0, your information gain is going to be 0.971, and you're basically done. But we're not done this time.
Maybe.
So
You just add another.
for this calculation here, you might say, oh, you know what I should do? I should take this proportion out of everything in my data set. I should say 1 out of 5 and 2 out of 5, but that's wrong.
If you just have one variable.
Remember earlier in this example, where is it? When we did the split between these two, and when we went to the right side and we said E of right, We did the proportions out of the total here. They were out of 6, not out of 10. The same thing applies here.
There's libraries for.
Our splits proportion is gonna be out of the total amount of items inside of that split. So it's gonna be out of 3 instead. So if you look here, it's gonna be 1 true out of the 3. So 1/3 times log, -1/3 times log 1/3 minus 2/3 log 2/3. That's what our entropy of the false branch would be. It's out of the total number in that split. That number is 0.918. Now we're gonna calculate the overall entropy. Mitch, you guys remember what the formula is for overall entropy?
We've reached a decision.
It's the weighted average. So we have to figure out what's the total amount overall, so in everything in our data set. That's in the true branch and overall, which is in the false branch. So if you look here,
Same thing.
2 out of 5.
Yeah, exactly.
2 out of 5
See,
times the entropy of chest pain
exactly.
in the
You're
true
all
branch
It's like you
plus
could make
3/5 here
your model in the world.
times the entropy in the false branch.
And then
So this is the overall entropy of this branch.
get them.
And that number is
We're saying 90%.
0.551.
Much lower. And then basically. That's.
Now that we have the overall entropy, we can calculate the information gain now, which is the entropy of everything minus the entropy of the chest pain. I'll call this
But then it takes
C,
years to
don't
get
mess
it
it up with the
over
other one.
because the energy of
So the information gain of chest pain is going to be
But if
0.971
you're able to
minus
you want to a web. and then
0.551.
type in,
This
question
is
two and so on.
0.420.
It gives you an answer in a relatively quick time. No, that's useful. Is it right all the time?
So that's how you
No, but it's a
calculate
lot-
the entropy
it's
of
a
a
lot more
split. Now you'd be like,
useful
oh, am I done
instead
now?
of, like,
No, you have to do
10
this for
minutes to
all of
get
your
back to
features.
the
We have to do this
answer.
for smoker and for daily exercise. And whichever value has the highest information gain out of that will be our first split. Remember, you can have multiple splits because your decision tree can be multiple levels. You can have multiple of
In spring.
these nodes here. You can only have one node if you have a perfect lineup between one of your features and your classes. So we'll do smoker next. Okay, we're just gonna do exercise instead because I think exercise is a little easier. And I'll just show you guys the final decision tree. So exercise. Okay, who's in our true branch for exercise? Yeah.
Pretty sure it's like.
Who's gonna be in our false branch? It's whoever else is left in the. And so now we're gonna do the true here. We have to map these to their actual values. That's true, false, false. I'll just do the same here real quick. So here we can look at our proportions again. This is the same number as we had before. 1/3 minus 2/3. Oh, 2/3. Same number as here, that's 0.918. And then here, it's TNT for the false branch. So if you look at the entropy here, just think about it. If you have two things that are of the same exact entropy, the entropy here is gonna be, it's 0 because they're both the same thing.
I'm taking it.
So already, if you look at it from here, just from the overall graph, you can see that exercise doesn't line up that well with the overall heart attack values. I mean, not overall. It lines up exactly the same as the chest pain values. So you know that this value is going to be the same as, or it's going to be as good of a pick for splitting upon as chest pain. So basically, these are all the calculations, by the way. It's the same stuff that we're doing on the board. I can't see it, but it's over there. Same calculations what we're doing on the board, but it's also all that because we're running out of time. So we want to split on either chest pain or exercise. The final this is the final decision tree. We split on chest pain and then we split on exercise, which makes sense if you think about it, because chest pain and exercise are two best entropies anyway. I'm gonna keep moving. So the next idea we have is regression trees. We're not gonna do the math for this. We're just gonna talk about it instead. So you can think about this visually as the decision tree sort of blocking out parts of the graph and coloring them. It's like playing 20 questions, but with math. It's the same process as we just did, but you might be thinking, wait, how can you calculate entropy in this case? We don't have discrete classes. We can have any number now.
Yeah.
So instead of using entropy or Gini impurity, you can use something like mean squared error, which is something that you use in normal regression problems anyway. So you split the data set at each node along one dimension. You can see that here we're splitting upon, we only have one dimension here, so we just keep splitting upon X until we've sort of created like a little box and a little class around each one of the values. To calculate the best split, you calculate MSE upon each potential threshold per dimension. Whichever one has the lowest mean squared error is used for the split. Now, this is sort of like the visualization of a regression decision tree problem. You can see that at each one of the values of X, which we have one dimension of, we're creating a split upon it and sort of blocking out which class it is by doing this. If you're not wondering what is going on in this graph, you can see some green boxes are appearing and disappearing. This is the idea of depth. You can define a max cutoff of how big your decision tree can get. Because with no limit on how big your decision tree can get, it can get very, very specific and very, very fixed on what the classes are based on your data. What does this problem sound like where you let it go on for too long and get super duper fixed on your data? Yes.
Overfitting.
It's overfitting, exactly. With no limit upon what your decision tree can do, it's gonna get very, very fixed and overfitted to your data, which is why defining a max cutoff or max depth is very important. You can also define other things like min samples. You have to control how many samples can exist within one leaf. The lower this number is, the more numbers of leaves you can have at a certain amount at a certain leaf. This serves as a way to prevent one leaf to pertain to a very, very small sample of your data that is not representative of the entire data set. So the next thing we have is XGBoost, which stands for extreme gradient boosting. This is sort of like a bunch of decision trees, but it's not like random forest. Random forest is like a bunch of decision trees. This is sort of like one decision tree getting better and better and better over time. It uses something called boosting, where the first model, I'm not going to draw, but think about it. The first model is trained on the entire data set, just like we already did. And this usually works very well if you have a very, very large data set. First model gets trained on everything. Next model looks at how well the previous one did. If the previous one made some mistakes, adds certain amount of classes, it goes and in the next iteration of its training fixes those mistakes. So the better and let's say that like for certain amounts of classes, it's predicting terribly. Before the next iteration starts, it goes through those and finds those bad predictions and increases the weight upon it. So with the next iteration of its training, it will make sure, hey, this data point is highly weighted. We should care more about this point, so it's more likely to do better next time. It's like you take your first midterm and you do so bad on this one topic on the midterm. So the next time before your final happens, you're like, you know what, I'm gonna spend extra time studying this topic. So I take the final, I do better on it. It's the same idea here. You look at the data set, you do all of your training. If you did bad on one part, you redo that and you add more weights to it to focus more on it and predict those better in the next iteration. The second tree trained corrects the mistakes of the previous one. So it's really good for performance, speed, it's great because it will perform very well. It works very well on large data sets. So this being said, what can be bad about taking the same thing, applying weights to what's wrong and doing it again and again? There are some potential problems with that. Overfitting again, you can get overfitted. We only have 4 minutes left, so I'll probably go over this next time, or I'll just show the code.
That's something right now. Yes.
Oh, it's very dark, very dark.
Yes.
During
Well,
the
you'd
summer.
have to check your policies, but yeah, you can transfer stuff. Over the summer.
No, not here in summer, but like.
Okay.
on this
It was a
computer.
really funny example to me. We were gonna predict how drunk someone gets based on which alcohol they're drinking,
Actually do.
but I don't think we have enough time for that. So I was gonna show you guys.
Also means.
This is our data set. It's their favorite number, hours of awake, number of shots they took, which year they're in, and whether or not they're drunk. You want to predict if they're drunk.
Or the one they're in, yeah. Do that.
And this is how it would look like in your we did if you wanted to do this in
There's so much technology.
scikit-learn.
And then you can.
Okay, scikit-learn. You use this thing called decision tree classifier for that.
These aren't even like
And
CS
if you're
based.
data, if you look here, right, you're like, oh wait,
Maybe.
and whenever we've done our examples, all of our values, even if they're strings, it's been fine, right? Because we just hand calculate everything. Your computer can't do that. So one of the ways you can do that is you take these values here, the letter ones, and you map them into numbers.
Yeah. Like this.
Like.
So in our case, you'd make first 0, second 1, and third 2. That's how it would work. You don't have any
So I
go
might
forth in
just.
this data set.
Might just. fill in
Same thing with the type of alcohol. You also map those to certain numbers. I'm just gonna run this.
Three and then like experience.
Oh, you can get like 3 minutes.
Actually, that would make sense. The third and fourth year.
Now we define our features, what we want to use. So
Yeah, some
we have
stuff
favorite
is
number,
like-
type of shot, shots taken in the year they are, and then the model is gonna do what we've been doing by hand
Yeah, some stuff,
automatically.
like, on campus
And it does
is,
that
like,
with fit.
for, like,
So if you wanna
research,
be more
like, they just give
specific,
you
oh, I
credits,
have
but there's, like,
specific
not
things
a
that I
lot.
want to use. There are
Yeah, that's not, so like not a lot to.
Unless it's
So
like.
all of these different
unless-
arguments you can give it. Remember we talked about Gini and entropy? You can give that what you want it to use. Automatically, scikit-learn uses Gini in order to do it, but you can use entropy as well and log loss. The splitter can be best or random. Of course, you want it to be best, but you can make it to random instead. Why would you want to use a random splitter in a decision tree?
Eligible. But like it's through.
It helps if you want to reduce overfitting, because if you keep using the best, you might get a very specific subset. If you use random every once in a while, you'll be able to represent a class that may get underrepresented. Depth is somewhere in here. There's min sample leaves, there's max depth,
That's this is
a
what.
bunch of different
Yeah.
choices here. It trained, and now we're gonna look at our,
It's just a whole.
our,
file just for, like,
Yeah,
just
it's just
tree
fun
here.
in everything.
you can look at it by using this thing called
And it
plot
accounts
tree.
for, like, you have,
And I'm
like,
wondering, okay,
like, research
so
shots and whatnot.
over here you can see that the first one we choose is shots taken. Intuitively, that makes sense. If you want to know how drunk someone is, you ask them, how many shots did you take? That makes sense, the decision tree chose that, right? The thing that you don't want to use usually is, type of shot or random or your favorite number. I'm not gonna ask someone their favorite number. Right, that doesn't make sense. And the decision tree figured that out because it is truly random when you use random number in your
build so many connections.
in your like when it was figuring out what the best entropy is, it's not gonna use random number because it's gonna be a very high entropy.
Well, like
So that's basically how you make a decision tree. We use Gini index to measure which feature is best.
It's just
Remember, a
genius.
low Gini index that's close to 0 means it perfectly, well, it's called a segregated split. I know it sounds bad, but it's not. It just means it's a perfectly even split.
keeping track of stuff and
Close
it's
to
like,
0.5 means a perfectly even split right down the middle, and you want to use the strongest feature that we have.
it's pretty good.
So basically what this means is that if they took more than 6.5 shots, they're drunk. If not, we go down to our next strongest feature, which is if they've taken less than 4.5 shots.
It was the one that I did.
And based on this, we finally go down to the type of alcohol they drink, and we also use that to decide. So overall, this is how you make a decision tree in Python. I know we went over this really fast, but I think that's it. That's everything we have. Let me plug this back in so we have light again.
Oh, not like the personal picture though, but it was gonna take.
But yeah, that's everything. Do you guys have any questions? Yeah, that's it. That was our presentation. Do you have any questions? Questions? Okay, I hope you guys learned stuff. That's it.
Yes, thank you. And we just have a few more announcements to make real quick. If you are still here, you're a real one, so thank you guys for sticking around.
No, it doesn't.
So now you get some good info that everybody that left is gonna be late to. So we have a few events planned for this quarter. So I'll go over some of those. Yeah, I know, I put his face pretty big on there. So yeah, one event we have is on January 27th. So we had this guy, his name's Tony Shi. We had him as a guest speaker last year. And he graduated from UCLA with a degree in business economics. And then he got his master's degree in finance at Johns Hopkins. And he's currently a senior business intelligence analyst at Capital Group, which is a company around here in the area. So he's going to be coming on that day, just going to be doing some speaking on some insights he has at his career and professional development. And he'll be taking any questions you all have as well. So that'll be a pretty good opportunity. That's on the 27th. And then on February 10th, and both of those are going to be in this room, by the way, we are doing a collaboration event with the Women in Cybersecurity Club. They're typically more focused on like grad students and stuff, but they wanted to collaborate with us. And what we're going to do is we're going to set up around 8 tables here in this room. And we're going to get either grad students, PhD students, or people in industry to be at each one of those tables. And it'll pretty much be a mixture, like you can go and walk around, go up to them, ask questions. They'll just be sitting at their table, maybe presenting some of their work they have, and they're just open to talking to anybody. You can ask them questions about like their career paths, maybe if they know of any job opportunities. So that'll be a pretty good like chill mixer type of event. And then also have some additional projects in addition to the ones that Scrum Adventures came and presented today. We have 3 other ones that we're working with companies for. So the first one is with a company called GoFly, which pretty much they're trying to help people with clothing and returns. And they have products already where you can scan a piece of clothing and it scans it and tells you if it's good to return or if you should donate it or try to resell it. So they're trying to get people to help them out with that, to like build a data collection of that so that it can more easily be able to identify these clothing pieces. So if you're interested in computer vision or you have expertise in working with APIs and data storage, that might be something that you're interested in. And the next project is working with a company called Cactus that reached out to us. They are, they were actually a part of Y Combinator, I think this past year. So they've raised a good amount of funding, and what they're trying to do is the fastest to deploy mobile AI. So AI is pretty, you can deploy it on your laptop, but they want to make it more accessible on mobile devices as well. So that's going to be a more open kind of project. They're looking for students that are looking to help them out to build their product and to be a part of their team. And if you join them, they're willing to give whoever joins like open resources to help them out. And if you do make progress at them, like they'll put your name on the publication that they have, and you can be a part of their team as well for that. And then the last project is working with a company called Starboard, and they're a company that basically they help out home buyers. And when you're buying a home, there's a lot of documents that you need to fill out so that the people you're buying from, they know that you're legit and you actually have the amount of money you say you have, and a good history and stuff like that. So Starboard is simplifying the home buying process. So they reached out to us. They're looking for help to basically make a way where AI can go and scan through documents that, let's say if someone's applying for to buy a home and they upload documents like such as like tax forms or like past employment documents. So they want to have AI just to be able to go and scan that automatically to help out their loan officers in the company. So if that's something that interests you, we're going to be releasing applications for all these projects within the next week. So look out for those it's either going to be on our Instagram or Discord. We'll post it in both of those, as well as the Scrum Adventures project. So be on the lookout for those. It'll probably be a Google form where you guys can just submit a resume, and then we might ask a few questions to see who could be the best candidates for these. So yeah, if y'all have any questions, feel free to reach out to us. And yeah, thank you all for coming. That's gonna conclude the meeting today.
They never want you to be late. They always want you to be strictly within your, yeah.
Oh, yeah.
Because mistakes are like stupid.